In this episode of KubeFM, I got a chance to speak to Nicholaos, and he discusses how his team re-architected Kubernetes native authorization using Open Policy Agent, also known as OPA, to support scale, latency guarantees, and audit requirements across services. You'll hear us talking about their move to batch evaluation to reduce OPA decision latency under high concurrency, how CPU throttling and Go garbage collection impacted performance under Kubernetes resource limits, and the trade-offs between OPA as a sidecar versus daemon set versus WASM-based integration. Nicholaos also explains how they worked with Styra to improve audit log indexing in Elasticsearch for better queryability and retention, and also how they built out a custom observability layer to track OPA decision timing, cache efficiency, and failure modes. As Nicholaos pointed out in the episode, the hard part isn't writing policies. It's making sure they don't break when you scale them to 20,000 requests per second. Whether you're building secure service-to-service auth or trying to scale policy enforcement with real observability, this episode digs into what that actually takes in production. This episode of KubeFM is sponsored by LearnK8s. Since 2017, LearnK8s has helped engineers all over the world level up through in-person and online courses. Courses are instructor-led and can be taught to individuals as well as to groups. Students have access to the course materials for their entire lives, and courses are 60% practical and 40% theoretical. For more information, go check out learnk8s.io. Now, let's get into the episode. Welcome to KubeFM. What 3 emerging Kubernetes tools are you keeping an eye on?
So currently, I'm keeping an eye on Open Policy Agent, Flux CD, and Trafic.
Good. Any particular reason?
Open Policy Agent, for probably the obvious reason that we're going to be talking about today. I've been working with it for quite a few years now, I guess you could say. And it just has a massive amount of flexibility and, I think possibilities into the future. I would love if I could make a firewall out of it, for instance. Flux, because it's simple, easy to use, and Trafic, to be honest, because we're currently using it on a project that was built by someone I respect greatly, who is no longer with Gusto, unfortunately.
Okay. Now, for people who don't know you, what do you do and where do you work?
So I am a senior staff, I should say, product security engineer here at Gusto. I work primarily on authorization. We are an HR payroll benefits company, and I work on improving authorization with Open Policy Agent, which uses logic programming to define authorization policies.
And how did you get into cloud native in the first place?
After my time in Montreal, which we can talk about later, I was introduced to cloud at the Lumen Cloud Computing Center. I probably have the name on that wrong. It used to be called CenturyLink. So I moved from Montreal to St. Louis after school and after my games career, and I got both backend and front end experience at that company with the billing team backend, and then DDoS mitigation for the front end.
And before becoming cloud native, what were you? I know you alluded to working in games, but go a little bit deeper on that if you can.
For sure, yeah. Well, I am from New Hampshire originally, where I'm coming to you from now. As many tech enthusiasts are, I was very into games growing up, and I made it a personal goal. I said, I don't care how hard it gets, I'm going to go into games. I'm going to keep studying very hard. And yeah, so in Montreal, it's a pretty big game city because of tax policy from the Quebec government, which I think they're phasing out now, unfortunately. But it's the reason you have a lot of big studios up there like Ubisoft and EA and Eidos, obviously, where I worked. So throughout school, studied really hard because everyone wants to go into games. It's kind of like the gateway drug into tech up there. Basically, just really had a great baseline knowledge of the low level technology. So starting from assembly, going into C, C++. Games is one of those industries that still uses C++ because they want to squeeze every ounce of speed they can out of the hardware. And then my wife moved to St. Louis for medical school, and I went along with her. It's worth it. So the actual places I was working, well, like I said, were Eidos, and then working on Deus Ex Mankind Divided. And then before that, I was at Square Enix Montreal working on Hitman Sniper, which was a mobile Hitman game. And then I was involved in the founding of a studio where we worked on a game called Last Year the Nightmare, an indie studio, which didn't end the best way. We can get into that later if you want, but I'll leave it there for now.
Okay. And the Kubernetes ecosystem moves very quickly. How do you stay updated?
So I'm going to be 100% honest. I'm not a Kubernetes expert by any means. I keep up to date by just reading the documentation to find the things that I really need to know about. I keep up with recommendations from the company and the team, read up on them when they come up, and once in a while I'll watch a KubeCon talk or two.
If you could go back in time and give one career tip to your younger self, what would it be?
So there are a couple things. So for a more general audience, I would say, as is mentioned at the end of the blog post, there is this other blog called The Law of Leaky Abstractions by Joel Spolsky, who I think was the CEO of Stack Overflow for quite a while. And I'm just like such a fan of his work. Like everything that he writes, most things that he writes are really, really insightful when it comes to not only like the tech, but the business that the tech has to interact with. And that's always where we have the most fun, I think, as engineers, is in that kind of clash of priorities that can occur. So the law of leaky abstractions, in my opinion, is the one thing that I think going forward too is kind of going to separate the talented engineers from AI. That's the one thing that AI I don't think is going to be able to do for a while, at least. We'll see. I'm not an expert in that either. And, these things, you never know how they turn out. But understanding the law of leaky abstractions, basically that's a motivation to keep studying up and down the stack so that you can be ready for the bug that is very scary in the night and that's going to come after you. And you're going to spend like 2 weeks trying to figure it out. Do I want to get to I don't know if I want to give away what do you call it? Like the most important quote from that, but I don't know if it'll come up later. So I'll just say it. I think the law of leaky abstractions says that all abstractions leak, meaning like whatever it is, TCP, any higher level programming language, any two pieces of software that are like interacting with each other, one higher level, one lower level. And when they leak, we realize that they save us time working, but they don't save us time learning. And to me, that is such a profound insight that I don't think I would have gotten in any class. But it's motivation to go to class and really pay attention, because there's usually a reason you're learning what you're learning. I said there were two things. The other thing for myself, like personally, I would give myself the advice that I should I should develop an understanding of my strengths and be honest about them with myself. Because, for example, I really wanted to make my own compelling video game from scratch, like bottom to top, and with no help. And, I could do some of those things. I was a pretty good designer and engineer, good UI designer and engineer, but you need to be a great artist. You need to be a great modeler, great level designer, composer, low-level engine developer if you don't want to take something off the shelf, right? I always laugh when I see someone, I'll see a post like, oh, this person created this game all by themselves. I'm like, really? Did they code the Unreal Engine from scratch? 15 million lines of C++, really? And I mean, like, I'm not to try and take away from their accomplishment or anything, but as you get deeper into every industry, you realize how many folks are necessary to get it to happen from the bottom up. So that's the advice I would give myself. Know your strengths, realize where they are, and for your weaknesses or the things that you are not strong in, let's say, try to find a couple friends with those strengths so that you can build a team and make your dreams come true.
As part of our monthly content discovery, we found an article that you wrote titled Super Scaling Open Policy Agent with Batch Queries. So the next questions that we're going to be looking at are designed to explore, the topics covered in the article further. Now, authorization is a critical concern for Kubernetes administrators. But before we get into implementation details, could you explain why traditional authorization approaches often fall short in containerized microservice architectures?
Yeah, so this is a pretty big topic. It's touched on in the previous blog post that's linked at the beginning of the one we're talking about. But basically, looking at the 2021 OWASP top 10, there's probably by the time this is coming out or a little bit after, the 2025 ones will be out. So we'll see where it lands now. But in 2021, the number one vulnerability for web apps was broken access control, which is another way of saying broken authorization. The main reason for this is that authorization is just often very fragmented, especially if you're working in a multi-service architecture, and especially if you're working in a multi-language, multi-service architecture. So broadly speaking, before OPA, you had two kind of approaches to authorization you could take. In the code-driven approach, and then there's the data-driven approach. So in the code-driven approach, your authorization is coded directly into your endpoint code, which is fine for prototypes and small projects. But as you start to grow, you start to realize, oh, we can't really represent all of the policies, especially with a domain as complicated as HR and payroll and benefits. We can't really just put this logic in the code and expect it to work every time. You have the problem of, more endpoints, more models, more data, more users, more access levels, more services, possibly, like I said, with more languages. So in addition to all of these issues with, the developers and the new endpoints and the complex policies that you have to implement, it also generally ends up tightly coupled with the rest of the code. And I mean, I guess you could say that kind of coupling happens within the service, but still is not great. It's the kind of thing we'd really like to decouple into its own service. But again, before OPA and before decoupling it into its own service, you have this other end of things, which is data-driven authorization, which is bad for another reason, or is limited for another reason, which is, the classic example is role-based access control, or RBAC. So everything is data-driven, meaning you have a role or several roles as a user. You can log in as any of those roles, or you might be logged in as all of those roles at once. And the authorization system has some kind of policy that basically maps your role to the resources you can access. And normally, that's fine for most things, but if you need any kind of logic in there, you're either going to have to make a special role for that particular person, or you're going to have to mix and match styles, meaning some of it's going to be data-driven and some of it's going to be code-driven. The problem there is that the audit problem gets a lot bigger, because if you want to know as a security team, let's say your company's growing, you have a security team, and you want to know what the policies are, you have to go through all the services, make a bunch of notes, pray that they don't change while you're doing this huge audit, look at all the data, and it just becomes very overwhelming. So yeah, that's kind of the landscape before OPA. So that's mainly the reason that the traditional authorization approaches fall short.
Now, you've advocated for Open Policy Agent, or as you referred to it as OPA, as a Kubernetes native solution for authorization. How does OPA's architecture integrate with Kubernetes, and what makes it particularly well suited for container orchestration environments?
So I think what's best about it is its versatility. It really depends on how deep and scalable you want your authorization to be. And by this, I mean both Kubernetes as well as application authorization. We happen to use just application authorization, or I should say I've implemented only application authorization. So just one open node running by itself can handle like a lot of authorization requests. It is remarkably performant. And especially if you're willing to do a little time-space trade-off by optimizing the policy bundles, which basically uses more RAM but takes less time to evaluate, you really shouldn't need to, like, it's much more likely that your bottleneck is going to be like the network latency between OPA and your service. There's things you can do to reduce that as well. But yeah, if your policies happen to be taking a really long time because they're really complicated, you can make them faster. Or if you need the kind of super scaling behavior I'm discussing in the blog post, you can stand up as many OPA instances as you need, even set up an auto scaling group if you want. You can bake policies in with the image or have OPA fetch it periodically from some external source. If you need super low latency, you can co-locate OPA and server pods on the same node, or even run it as a WASM module right on your server pod. In terms of Kubernetes authorization, like I said, I haven't set this up myself, but Rego, which is the logic programming language that policies are defined in, is purpose built to be really efficient in terms of reading, writing, and executing evaluations on the kind of data-driven documents that Kubernetes deals with all over its ecosystem. So Kubernetes is going to be a lot of YAML, which is trivially serializable to JSON. So my understanding is that OPA can act as an admission controller in Kubernetes, making arbitrary policies easy to write and deploy, with the benefit of those authorization requests already being serialized as admission reviews. So it takes in a JSON document for authorization, performs a logic programming policy evaluation on it, and then returns some results. And it does that in a declarative manner. There's no side effects, purpose-built for evaluation. You can't have recursion or infinite loops or anything like that. So you're guaranteed to return something. You can do recursion in like a data-driven way. There's a way to do that I get into in the last blog post. If you link to that and then you scroll all the way to the bottom, I think it's in the appendix. But yeah, that's what makes it really good for Kubernetes.
Let's talk a little bit more about deploying OPA in Kubernetes. What are some common deployment patterns, and what considerations should teams make when choosing between sidecar, daemon set, or other deployment options?
Yeah, so the main patterns, like you said, individual pods, replica sets, auto scaling groups, daemon sets, sidecars, and of course WASM modules. So those are the common patterns. With all things, it really depends on your use case. The main things to consider are latency requirements, bandwidth, development overhead, the feature set you want. So like WASM modules, they don't have all of the standard library. Like if you go and look at the OPA documentation, they have like standard functions. So not all of them are compatible with WASM, and cloud cost, and yeah, I suppose policy size as well. So if you have optimized policy bundles, like I was saying before, they can get a little bit big. So if you can afford the RAM and you need the latency savings, go for it. You also going to want to have really good observability into what parts of the OPA authorization request is taking the most time, if time is something that you're concerned about. And so, yeah, with all deployments, like napkin math, simulating the load in order to observe CPU and memory usage is key. So basically on your local machine, as best you can, right? Start hitting OPA with the types of requests that you think you're going to need to hit it with, and then measure the response, and then do some logging in your application to see like how many of these requests happen every second, every minute, an hour. And then just do some napkin math. You might also just need to consider like whatever the round trip latency is. I think for us, in our co-located, like we have OPA pods and server pods on the same node, you can expect a couple milliseconds. Even with, we tried to use Unix sockets to make it quicker. I'll give you a free tip. It doesn't help. If you want to get better latency than on node performance of a couple milliseconds or so, you're probably going to be looking at WASM modules at that point.
Now, in your article, you mentioned performance challenges with OPA and Kubernetes when handling batch authorization requests. Could you explain the specific issues you encountered in your cluster?
Right. So we didn't actually have much of a bottleneck performance-wise. We did have these so-called batch policies in OPA, which were quite performant before I started this project. But it would be very easy to imagine a scenario where someone just starting out with OPA could run into a situation where you're performing one authorization query for every item in a long list, and then that network latency will just add up and could add up to like seconds on a particular request. So in our case, we couldn't search the batch policy's audit logs. So this is another thing that that OPA has over traditional authorization methods, is that it has audit logs built in, and meaning that it can just export them. And in this case, you can export them to like S3 or whatever, but in this case, we're exporting them to Styra's DAS service, DAS, which I forget what it stands for, but it doesn't really stand for anything that's relevant to its function, I don't think. So basically you can, they get indexed and you can search them with an Elasticsearch type of query. And you can't do that for batch logs, because the way that they end up is, okay, you normally have like, and again, I go into detail on this on the blog post, but normally you have like fields that you can index on, but with the batch request, just one big audit log gets sent to DAS for like hundreds of queries, and that can't be efficiently indexed under that system. So for these unsearchable batch policies, we wanted to keep the parallel performance of our batch policies, but we wanted to separate the decision logs out into individual decision logs as opposed to batch decision logs, so that they would be indexable and queryable in DAS, which is what started me on this journey.
You discovered some pretty interesting interactions between Kubernetes resource limits and Go's runtime behavior. This gets into some advanced territory. Can you explain how CPU limits in Kubernetes affected OPA's performance?
Right. So this is a classic example of false assumptions in software engineering, also known as the road to hell is paved with good intentions. So for some quick background as we make our way through this article, what we ended up doing to solve the Styra DAS issue was that Styra graciously added a feature to split the batch authorization requests into individual ones before evaluation, evaluate the requests in parallel, send the individual decision logs to DAS, and then stitch them back together for the response. So that pretty much gave us what we wanted. What this ended up doing in practice was taking part of the whole operation out of Rego land with our old batch policy and performing it in Golang, or in the Go language instead, which is what OPA's implemented in. So again, this does get into advanced territory. I don't know the exact details of how, the OPA is going to be evaluated as in the logic programming, but my understanding is that it can make assumptions that make the evaluation a lot easier than you could in an imperative language like Go. So for that reason, you can still get good performance out of Go, but you need to make sure that it's operating at its full capacity in terms of what we're going to discuss next. So it was working great on my local machine, but once we got it into the production cluster, we were seeing considerable slowdown, even after some trivial optimizations like reducing the request size. So there were like properties of each request that were beefing it up like, I don't know, 10 or 15 times, or maybe like 100 times. And so we had like a common input that, all right, let's take, because all those were common. It was a bunch of repeated data. So we're basically compressing it down a little bit to reduce not the network latency, perhaps a little bit of that, but also like the processing latency on each end of serializing and deserializing it. So once we had that, we thought it was a garbage collector issue because of some of the timings that OPA was giving us, and you could see that in the article as well. We tried to tweak the garbage collector values in Go with no luck. Eventually, what I found out was happening was that it was a mismatch in expectations between Go and Kubernetes. So Go is designed to be highly parallelizable via Go routines that run on Go threads. But if you're the designer of Go, you have a question to answer, which is, how many threads do I spawn to run the Go routines that the developer/user throws at me? Too few threads, we run into a situation that doesn't have a very well-established word, but ChatGPT tells me it's called context switch thrashing, as opposed to traditional thrashing, which has to do with memory paging systems. But the concept is similar. Basically, context switches between threads aren't free. And so if you have too many threads fighting over too few CPU cores, it's conceivable that you could be spending more time switching between them than actually executing them, which is a big problem. So Go's answer to this question is to basically spawn as many threads as there are CPU cores reported to it to the operating system, reported to it by the operating system by default, or an override value specified by the user called Go max procs. So that works fine if the number of CPU cores that the OS reports is actually available to Go. But as we learned, that's not the way Kubernetes works if CPU resource limits are enabled. So since OPA is co-located with the server pods, we want to be judicious about CPU limits so that even though it's normally very well behaved, in case it goes haywire, we don't want it to hog all the CPU and mess up our servers. So we had a pretty small limit of it. A small limit on it. And so basically what happens is that even though Kubernetes will pass through the number of physical CPUs present on the node reported to it via the operating system, it will only give you the number of physical cores, meaning it will only let you run on the number of physical cores that is the ceiling of the CPU request you give it. So if you ask it for 750 millicores, which we did, it won't give you 25% of 3 physical cores, even if you have 3 threads. It will just give you 75% of 1 core, and your threads will have to fight over that 1 core. So in our case, Go was spawning something like 8 threads because there were 8 cores present on the machine, but the limit was 750 millicores, which only gives us 1 physical core. So all 8 threads were fighting over that 1 core. And the way I discovered this was basically on a hunch. I thought the Go max procs would be 1, and I thought I was bumping it up to 2. What actually happened was the Go max proc was 8, and I bumped it down to 2. So there were just fewer threads fighting over that 1 core. But basically, you ended up the final result of that was that we had about 1/5 of the performance that we would have expected from our local tests and from the batch policies that were running on production earlier.
After discovering this issue, you mentioned benchmarking different configurations. What was your methodology for optimizing Open Kubernetes, and what final configuration did you settle on?
Right. So since our variable space wasn't particularly huge, I originally tested setting Go max procs from 1 through 4 on 1 through 4 CPUs for a total of 16 tests. I just wrote a nice big bash script to go through all those possibilities and ran a sample batch authorization request through like 30 repetitions each. And then I collected all those metrics that OPA generously reports, and I aggregated that into like averages, and I think I may have done percentiles or like min, max, average, basically the main things that you're concerned with. And then I put that onto a nice big numbers spreadsheet because I'm too cheap to pay for Excel, and numbers works fine. I just got used to it before I got to Excel. I'm sure there's going to be a lot of folks who are going to explain to me why I'm making the wrong decision in my life, and that I need to find the light of regular Excel, but it is what it is. So after going back and forth and presenting my finding with the infrastructure team, who again is understandably very protective of CPU limits and needed some convincing, rightfully so, we landed on 3 Go max procs on 3,000 millicores. Even though OPA uses I think maybe 1/10 of that in practice, it unlocked 3 physical cores for 3 Go threads to run on. And also, if you look at the graph, that's kind of where you start to get diminishing returns, is right around 3. It's never guaranteed what the correct number is for a particular number of threads, particular number of CPUs. It's usually the same number, but you can see some metrics like min, max, or average. Some of them will be off in certain ways because thread scheduling is a very unpredictable process, unfortunately. So anyhow, we landed on 3 cores, 3 Go threads. This was because we didn't want to give OPA too high of a CPU limit in case it started going rogue. But at the same time, we wanted to have similar performance to what we had before.
Now, let's talk about scaling OPA in a Kubernetes cluster. How did batch authorization improve your overall cluster efficiency, and what metrics demonstrate the impact?
So batch authorization queries by their nature are more efficient because you can pack more of them into a single HTTP request at a time. So even when you don't leave the node, there is network latency, and it's for us, it was like the real killer. I mean, it depends on your opinion. If like 1 or 2 milliseconds is like a killer, it can be as it progresses and you have more and more authorization requests. It depends on your use case. If you know you're not going to have those, it's probably not going to be a big deal. But for us, the more authorization requests you can fit into that round trip network call, the more efficient it's going to be. So we were able to push through about 18 times more batch requests than single requests in the same amount of time on average. Of course, this assumes that authorization requests can be batched, which is not always the case, but the cost of adding a request to one that is already batched is negligible and basically free in the grand scheme of things, unless you have ultra low latency requirements. It's also worth mentioning that authorization requests can be dependent on one another. So if you have a situation where you wouldn't perform one batch request if the previous one fails, you might consider just letting them all succeed through the request, batching them all together, and then at the end of the request, you send it off to OPA, and then you look at all the results. And if all the results are true on the way back, then you can return. You can return with an authorization. What do you call it? Authorization is allowed. The thing you got to be careful about with that though is like, if in that process you do mutations, you get a problem because it's assuming that previous authorizations succeeded. You can do mutations and you can do actual damage before returning that. So this is for read-only requests. If you have a bunch of, then again, the worst case scenario is you allow all the authorizations through. You might also allow some leeway for a bigger DDoS attack. So meaning like if you are processing all this data and it's hitting your database and you're assuming all these authorization requests go through, you need to be careful if you're hitting the database too much, because that's going to be an optimal scenario for an attacker. That being said, they probably have to be authenticated before this authorization chain happens. But this is just one of the ways you can think about batching these requests as well, given your circumstance. Don't do it blindly. But yeah, the main use case I have in mind was a big list of things, which it will work perfect for.
Authorization decisions need to be auditable for compliance and security. How did you handle decision logging in your Kubernetes environment, and what challenges did you face?
So I think I touched on this a little bit earlier, but Styra, which is the creator of OPA, I should mention, has this really convenient service called DAS. I think it's Declarative Authorization Service is what it stands for. And OPA can export all of its decision logs with a simple config line. And this service ingests all the decision logs from all the OPA instances, indexes them, and makes them conveniently searchable in one location so that you can search for example, all the actions taken by a certain user, or all the users that have access to a particular resource, that have accessed a particular resource, and when and how. And we ran into this issue where our legacy batch decision logs were basically not physically searchable. But the new batch API that Styra gave us fixed that. You can also do things like link your GitHub repo that contains your policies and simulate changes to them against inputs in your decision log. So you can go back to a previous decision log and see how it would change if you changed a particular policy. It's got really good authoring capabilities as well, in other words.
For Kubernetes administrators looking to implement OPA in their clusters, what practical advice would you give them based on your experience?
It definitely depends on what stage of development you're at and what kinds of resources you can throw at OPA. But the practical advice I'd give is the following. First of all, it's a good idea to get familiar with Rego. It's a bit different than what most folks are used to, being a logic programming language as opposed to an imperative. But Styra has really great documentation on it. There's a Styra Academy. The Rego playground, really useful for copying and pasting input JSON inputs, and then evaluating how they're going to produce outputs in real time. And you can change the policy and see how it's going to behave. It also has like linting and all the fun stuff. I would also just, as a side note there, like get buy-in from the team, especially if they're going to have to read or write the policies. Because here's the thing, you can write OPA for data-driven authorization. And if they're just going to be using the policies and you're the only one going to be writing and reading them, probably need less buy-in, but it's always a good idea to really explain the benefits to the team. Make sure that they understand that it is going to be a bit of an investment, but there is going to be a legitimate security payoff in the long run. Like I said, the ask here is high because the problem is high, meaning it's the number one vulnerability on the OWASP top 10. And the reason for that is not because it's a simple problem with like a simple CSRF token can fix, right? It's a complicated human-centric problem of authorization. And so since the problem is big, the ask is big in order to be able to fix it as best we can, given the tools that we have available to us. I would then get a sense of kind of what scale and latency you need for the open deployment, use some logging and some observability tools like Datadog to aggregate that data and get a sense of how much authorization you'll be throwing at it. Unless it's a trivial amount and one instance will clearly be enough to handle, you can place the OPA pods wherever they're needed, either via sidecar, a daemon set if you just want one on every node, or a standalone deployment on a dedicated node and you're okay with dealing with that latency, that's fine. As it pertains to the practicalities of scaling up an OPA instance, decide where your configs and policies are going to come from. Configs can either be baked into your Docker image, like you can just have a Docker file, get the base OPA image, and then put all your policies and or configs in there and then deploy that. Or your configurations can come from config maps. Policies can also be baked in, or they can be pulled from services like S3. StyroDAS also has a service where the policy bundles can be pulled from StyroDAS. When I say bundles, it's basically all of your policy files, which are .rego files, in a big folder hierarchy. You bundle it into a gzipped tarball, and that's your bundle. It can be optimized during that process. Like I said, adds a little space, reduces a little bit of time. We have also, in the past, I will be upfront about this in case anyone runs into it, we have run into bugs with certain optimization levels. So I think there's level 1 and level 2. Level 2, we've had a couple of bugs in the past. So another tip I might give is one of the things that we've done to alleviate or detect that earlier than normal is we'll run all of our tests and sample inputs from our StyroDAS. Like we'll take decision logs from the past and also our tests, and we'll run them on OPA with no optimization and OPA with optimization level 1 and optimization level 2, and make sure that they're all matching. You can do that in OPA or in Bash, however you like. But that's another little tip that will save some trouble if anything happens with the more optimized bundles.
Earlier in the conversation, you mentioned the book, The Law of Leaky Abstractions. It seems like it's particularly relevant in Kubernetes environments, given that there are so many layers from container runtime to orchestration to application frameworks. What lessons can Kubernetes administrators take away from your experience?
So I'm going to refer back to the words of the blog post that I said earlier, because they're extremely profound to me. And I think if every computer science student that I give advice to or ask me for advice, I tell them to read the same blog post, because if you can understand it, you're really going to have the motivation to study what you need to and just be pretty far ahead of everyone else. So the words are: abstraction saves us time working, but does not save us time learning. Basically, every lower level technology or abstraction that you don't understand under the abstractions of the primary one you're using incurs a learning debt, as opposed to a strict technical debt. And you don't pay that debt until the abstraction leaks or breaks in some way. and you have to go down the tech stack to find which one it was. The more you know about the layers that you're building on top of, the less time it will take to find that leak. I draw the parallel to the show House MD. I was a huge fan of this show back in the 2000s and still am. I've watched it too many times. I'm not going to tell you how many times I've watched the full series. I'm just going to tell you it's too many times. So I'm a borderline problematic fan of this show. And basically what happens, if you've ever watched it, is kind of like a modern medical play on Sherlock Holmes, where this Dr. House is presented with very weird medical cases that no other doctors will bother trying to figure out. And he often has to use, often incomplete, diagnostically relevant information under tight medically imposed deadlines to solve the case. And this is not unlike Kubernetes, where there are indeed a lot of layers. And for example, for security reasons, a lot of Docker containers nowadays don't have a shell. And so you really have to think deeply about the whole stack and the information that you have at hand, in my case, local environment versus Kubernetes environment, in order to have a chance at solving the issue without needing to take a sabbatical, basically, to learn all about the lower layers. And so, yeah, that's where I would conclude and say, like, it's important to know what you're running on. It's never a bad idea to go as far down the stack as you want. So if you want to go and read Linux kernel code, that can only help you in the end. That may be a little bit of an extreme example, but knowing all of these things and how they interact. It's also another note I wanted to add here was this will also bite you security-wise. So not knowing what layers underneath the current one, not knowing how they interact with each other, can really bite you if someone figures out how they do interact and uses it against you in the way of like some kind of injection attack or a buffer overflow type of thing. If you don't understand why these things happen or how they can happen, you're going to be a real disadvantage detecting intrusions and vulnerabilities that might happen, if someone really with a lot of, a lot of resources and time and a lot of reason to do damage for some reason comes after your system.
Sort of wrapping it up, notice from your social media profiles that apart from Kubernetes and authorization systems, you've got a diverse range of activities. I know you mentioned previously, game design, but also climbing and marksmanship. How do these various interests influence your approach to solving complex technical problems like the OPA optimization you've described?
So I don't know that they're strictly related, but I had this teacher in high school who I greatly respect, and I still go to visit once in a while. His name is Mr. Scott Gelzer at Co-Brown Northwood Academy in Northwood, New Hampshire. Shout out to Scott. And he was talking about the old physicists, and he said that what separated these physicists from, let's say what enabled them to solve really complex problems was that they had the ability to just sit and think about one problem for days or weeks or even years on end. And I think that's a bit extreme. So I like to, but there's value in it. So I like to have kind of a dichotomy where I think it's important to have the ability to do that. But I also think it's important to be able to recognize when you're not making progress as a result of that behavior, meaning you're going in some kind of pattern or circle and, pushing away from the desk, getting some sleep, going outside, doing a different activity. And while you're doing that activity, or I should say for myself at least, I always find my mind kind of not thinking about it actively, but just kind of like creatively going in different directions. Like, what if we try this? What if we tried that? And then by the time the next day rolls around and I sit down on that problem again, I have another direction I can take generally. And so I think being able to combine both abilities is critical to solving complex problems like that. And will be a more efficient use of time in the end too.
What's next for you?
Well, my wife is finishing up her residency here in New Hampshire. We're going to be moving to Missouri for a year before moving to the West Coast, hopefully for good, a year after that. So I'm not looking to make any big career moves for a little bit at least. I'm probably going to be sticking with Gusto for the foreseeable future. Gives you some time to hold out for, possible IPO. I'm not saying anything, but you can keep your fingers crossed. And I'm sure new fun problems will pop up to provide opportunities for new blog posts while I'm there.
Very good. And if people want to get in touch with you, what's the best way to do it?
Yeah, I don't really have a social media type of following, or I shouldn't say following, I should say presence. I don't have a social media presence because I have a feeling that if I did, I would inevitably say something that is non-technical and is political, and some people would not like it, and I just don't want to invite that kind of conflict into my life, especially right now. So maybe one day in the future, I will have a social, but for now, LinkedIn is the best way. Send me a request with a message. I'll probably read it. As long as it doesn't sound like an advertisement on first glance, I'll take a look at it.
That sounds fair. Well, thank you very much for joining us today and for sharing all your knowledge about OPA. Hope our paths cross soon in the future. Take care. Have a good one.
Thank you for having me. Bye-bye.